My dear students, in the previous video, we derived theorem 1, that is, any square matrix A can be expressed as a symmetric and a skew symmetric matrix. That is, A plus A dash is symmetric matrix and A minus A dash is a skew symmetric matrix. We have proved. We defined the symmetric matrix and skew symmetric matrices with examples, and I derived one theorem. That theorem states that any square matrix A can be expressed as A plus A dash as a symmetric matrix and A minus A dash as a skew symmetric matrix, where A dash is the transpose of the given matrix A. A is a square matrix with a real number entries. That is the theorem we have seen in the previous video. Now in this video, the second theorem we are going to see, theorem 2. So any square matrix, the same square matrix A, can be expressed as the sum of a symmetric matrix and a skew symmetric matrix. Any square matrix can be expressed as the sum of a symmetric and skew symmetric matrix. By theorem 1, we proved for a square matrix A plus A dash is symmetric and A minus A dash is skew symmetric. We derived in the theorem 1. Now in this theorem, the matrix A is expressed as, A can be expressed as the sum of a symmetric and skew symmetric matrix. A plus A dash is symmetric, A minus A dash is skew symmetric. A can be expressed as the sum of symmetric and skew symmetric matrix. This is, suppose if you take straight away, you apply this, you will get A plus A dash plus A minus A dash, that is equal to A dash you get cancelled, you will get 2A. So this A can be, straight away if you add these things you will get 2A. So to compensate this, you have to multiply it by 1 by 2. Then only you will get A. So that I multiply here symmetric matrix will be 1 by 2 and a skew symmetric matrix by 1 by 2. So commonly I have taken 1 by 2 outside. Now I will get A. So symmetric matrix is A plus A dash, you know. But 1 by 2, this is also by property of a transpose of matrix. Any square matrix K times of A, the transpose is nothing but K times of A dash. Ka the whole dash is nothing but K times of the transpose. So constant cannot affect the transpose of the matrix. Therefore the constant can be taken out. So multiplying a transpose of a matrix by a constant and multiplying a matrix by a constant and then taking transpose, it will not affect the symmetricity of the matrix. Therefore, I multiply 1 by 2 by A plus A dash and again 1 by 2 by A minus A dash. So, a matrix A can be expressed as the sum of a symmetric matrix and a skew symmetric matrix. Symmetric matrix is 1 by 2 into A plus A dash. Skew symmetric matrix is 1 by 2 into A minus A dash. See, 1 by 2 for the compensation of compensation only we are multiplying 1 by 2 by using the property K into A the whole dash equal to K dash. Therefore, any matrix is expressed as the sum of a symmetric and skew symmetric matrix. That is the property theorem 2. Okay. Now we will go to the exercise 3.3. In the previous videos, few problems we have solved in the exercise 3.3 and few more problems in the exercise we are going to see in this video. In the exercise 3.3, in our previous video we have some problems we have solved. Now in this video, the same exercise 3.3. I am going to solve some problems. That is problem number 7, first subdivision. In the exercise problem number 7, show that the matrix A is 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. Show that the square matrix A is a symmetric matrix. A symmetric matrix. That is our problem. A matrix is said to be symmetric when the matrix is said to be symmetric if the transpose and the matrix are same. We can say the matrix is symmetric. If A equal to A dash, then we can say A is symmetric. That is our condition. So what is A dash for the given matrix now? A dash is you consider interchange the columns into rows or rows into columns. Columns into rows. 1 minus 1 5. Second column minus 1 2 1. Third column becomes third row 5 1 3. See, after interchanging the rows in columns, the transpose is nothing but in the same A. 1 minus 1 5, minus 1 2 1, 5 1 3. Therefore, we have derived A dash equal to A. Therefore, given A is, given matrix, given A is symmetric. Given A is symmetric. That is the problem. First problem. And one more thing I am going to say here. In the matrix A, given matrix itself, you can see 1 minus 1 5, 1 minus 1 5. Minus 1 2 1, minus 1 2 1. 5 1 3, 5 1 3. That rows and columns are equal. The first row becomes first column. See, 1 minus 1 5, 1 minus 1 5. Second row, minus 1 2 1, minus 1 2 1. Third row, 5 1 3, 5 1 3. If your matrix is like that, if the rows and columns are same, then immediately we can say the matrix is symmetric without verification also. Therefore, because rows and columns are equal, therefore the matrix is symmetric. By mere seeing the matrix itself we can say. And one more problem, 7th problem, second subdivision. Seventh problem, second subdivision. Show that the matrix A, 0 1 minus 1, minus 1 0 1, 1 minus 1 0. Show that the matrix A is a skew symmetric matrix. Is a skew symmetric matrix. The given A is a skew symmetric matrix. We know that there is condition if A dash equal to minus A, then we can say then A is skew symmetric. That is the property. If A dash equal to minus A, if you transpose this A and verify whether it is equal to minus A, then we say that A is skew symmetric. Okay, we can now find what is A dash for this matrix given. A dash, just transpose 0 minus 1 1. First column becomes first row, 0 minus 1 1. Second column, 1 0 minus 1. 1 0 minus 1. Third column becomes third row, minus 1 1 0. Minus 1 1 0. A is 0 1 minus 1. A dash is 0 minus 1 1. Interchanging the rows into columns of A, it becomes a transpose of A. That is, first column 0 minus 1 1, 0 minus 1 1. first row. Second column 1 0 minus 1 becomes second row 1 0 minus 1. Third column minus 1 1 0 becomes third row minus 1 0 in third column. This is A dash. See, what is minus A? Multiply A by minus symbol. Minus into 0 0. Minus 1 into 1 minus 1. Minus 1 into minus 1 plus 1. Minus 1 into minus 1 plus 1. 0 into minus 1 0. 1 into minus 1 minus 1. 1 into minus 1 minus 1. Minus 1 into minus 1 plus 1. 0 into minus 1 0. See, A dash, after multiplying A by minus, we will get 0 plus minus 1 plus 1, minus plus 1 0 minus 1, minus 1 1 0. This is nothing but A dash. See, 0 minus 1 1, 1 0 minus 1, minus 1 1 0. Therefore, this implies A dash equal to minus A. Therefore, the given A is skew symmetric. That's all about the problem. Therefore, the given matrix A is skew symmetric matrix. Here also, by mere seeing the matrix, we can say it becomes skew symmetric, because by definition of a skew symmetric matrix, we know all the diagonal elements should be 0. Diagonal elements should be 0. Okay, above the diagonal elements and below the diagonal elements, still the elements are in opposite side. 1 minus 1 1, minus 1 1 1, minus 1 minus 1 1, 1 instead of 1 here minus 1 plus 1 plus 1 minus 1. So above the diagonal elements and below the diagonal elements, they are in opposite side. If it is so, we can immediately guess and we can say A is skew symmetric. By verification also we can find, by seeing mere matrix itself we can say is skew symmetric. It's a shortcut method to find the problem. Okay, next 8th problem. So you remember that the simple idea, if a given matrix A and A dash are equal, it is symmetric. If A dash is minus A, then given A is skew symmetric. That is the two conditions you have to remember. In the exercise 8 problem, in the same type, as in the case of 7th problem, you try to solve the 8th sum as your practice, as yourself. You have to solve the 8th sum by yourself, and I am going to solve 9th one. Find of into A plus A dash and of into A minus A dash. Of into A plus A dash and of into A minus A dash when A equal to 0 AB minus A 0 C minus B minus C 0. If it is a matrix given, you have to find out half of A plus A dash and half of A minus A dash. Half of A plus A dash means we have to find out a symmetric matrix of A and skew symmetric matrix of A. Half in A minus A dash is skew symmetric below. So, what is A dash? Straight away, if you interchange the columns into rows, 0 minus A minus B, 0 minus A minus B, A 0 minus A minus B, A 0 minus C, second row, A 0 minus C, second column becomes second row, third column, B C 0 becomes third. This is A dash. Our first condition is A plus A dash, A 0, A B, minus A 0, C, minus B minus C 0. This is A plus A dash 0 minus A minus B, A 0 minus C, B C 0. Adding just A plus A dash 0 plus 0 0, A plus minus A 0, B minus B 0, minus A plus A 0, 0 plus 0 0, C plus minus C 0, minus B plus B 0, minus C plus C 0, 0 plus 0 is 0. So this is a plus a dash. They have asked you to find out half into a plus a dash. If you multiply the elements of a plus a dash by 1 by 2, since all the elements are 0, you are again getting the same matrix or half into a plus a dash. See, half into a plus a dash is half into 0, 0, 0, 0, 0, 0, 0, 0, 0. It's again the same. Therefore, half into C. Therefore, half into a plus a dash is, again multiplying each and every element by 1 by 2, is nothing but 0, 0, 0, 0, 0, 0, 0, 0, 0. This is half into a dash. Next one, we have to find out half into a minus a dash. Okay. This is half into a plus a dash. Now we are going to see the next one, half into a minus a dash. A minus a dash. A minus a dash. A, what is A? 0, A, B. Minus A, 0, C. Minus B, minus C, 0. This is A. Minus A dash. A dash is 0, minus A, minus B. A, 0, minus C. B, C, 0. A minus A dash. Subtracting the elements of A with the elements of A dash. 0 minus 0. What is it? 0 minus 0, 0. A minus of minus plus A. A plus A to A. B minus of minus plus B to B. Minus of minus A minus to A. 0 plus minus 0, 0. C minus of minus plus C to C. And minus B minus to B. Minus C minus of minus plus C. Minus C minus C. Minus 2C. And 0 minus 0, 0. If you take the common element 2 out of the matrix, I get 0AB and minus A 0C and minus B minus C 0. This is A minus A dash. But we want half of A minus A dash. We want half into A minus A dash. See, we derived A minus A dash is, so half of A minus A dash equal to half into 2 times of 0AB minus A 0C minus B minus C 0. So cancelling 1 by 2 into 2, they get cancelled. You will get only the matrix 0AB minus A 0C minus B minus C 0. Therefore, half into A minus A dash is 2 cancel. You will get just 0 A B minus A 0 C minus B minus C 0 is half into A minus A dash. This is the problem. This is half into A minus A dash. So, we have completed the problem 9. And I will stop here. We will continue in the next video, the next problem. Thank you.